to wait until one of my favorite songs stopped playing, but I guess we'll get going. A little Post Malone. It's not so bad. Good afternoon. Thanks for coming. As Daniel said, a lot of this presentation has been built from discussions I've had. My main role as CTO in the sales organization, in go-to-market as we call it, is to work with customers and be with customers and interface with customers on what you all are trying to do, primarily moving to the cloud, modernization, taking advantage of analytics and AI, all that good stuff. And through those travels over mainly this year, there's been a pretty consistent trend that's developing, and I'm going to actually ask you a few questions about what you may think. It's at the same time here, and don't leave, please, but there's an OTF discussion just down the road, right? Open table format. Sub from engineering is doing that. And that is the basis of this discussion, but I'm not going to get to the details of OTF, right? I'm going to get into what's driving the usage of it within our customers and really across the industry, right? And then I'm going to talk a little bit about how we within Teradata are looking to address and support OTF and do what these customers like you are trying to do and what we're going to cover. So there's this is a very data-centered, I'm a data guy, right? That's what I do. When I've done implementations, my main role was to help users in the organizations that would use Teradata get at their data better, help access the data that they need. If they couldn't access it, work to make that more seamless, et cetera, through good physical design and other methods. But there's three topics. First, we're going to talk really quickly around the data diversity in the modern hybrid ecosystem. I don't think this will be a surprise for anybody. And then open data to simplify and enable AI-driven analytics. That's really the core of the discussion here. And two key topics there that we'll cover. And then enabling how Teradata will help support those trends and those strategies around open data. Pretty straightforward, and hopefully we'll have plenty of time for Q&A at the end. All right, so we all know data diversity is growing, right? We've had structured and unstructured since the beginning of Hadoop, right? Really, how many years ago was that? Over 14, 15 years ago, right? Raw source data, all these elements, the parts that you also have additional metadata management, and metadata management through open data catalogs is starting to progress. And there's still not really good metadata sharing between catalogs yet. It's been a problem for a number of years, where data might be shared, but you can't share metadata between platforms. And I think that's going to change too. And then you have on the bottom, source file types, open data formats, platform file systems. You got all these different file systems and formats, et cetera, that are available in this very dynamic world that we live in analytics and data processing, right? And we also have the vector embeddings and RAG references and prompt engineering and all the data associated with AI and generative AI in those particular cases. I didn't list everything, right? So with all that, the complexity of your data environments is growing, right? Relatively speaking. So one of the things that organizations are doing is, and we'll start on the left-hand side of the slide. So there's a renewed focus on data lakes. I'm kind of calling it data lake 3.0, maybe 4.0. I don't know. It depends how you look at it. Built around open data formats and open data catalogs, right? In the conversations I've been having, and this is going to be a little Q&A session for you all, they are driving, or large banks, financial services organizations, healthcare organizations are driving to what I would just generically call an open data lake. So how many know about open table formats in the room? Right? for those that know about open table formats who are looking to standardize on one or so of those open table formats. So the two open table formats that are prevalent in the industry are Delta Lake, originated by Databricks, and Iceberg, Apache Iceberg. There's also Hudi, is another format that's popular, HUDI, but really Delta Lake and really Iceberg's the leader in the industry as we see it right now, right? Apache, standard, Iceberg. So are any of you looking to completely standardize on Iceberg or Delta Lake within your environment, within your data lake at least? Okay. So this will be good because what I'm going to relay then is what some of these financial institutions, government, same way. U.S. Army is looking to standardize. I've been working with U.S. Army. The ForceCom organization out in North Carolina. And they're looking to standardize their data. They kind of have a closed data lake today built on Palantir, and they want to completely open it up to an open table format, probably Iceberg. So the first two trends, right? So open data lakes based on open data formats, and then open compute. So if you have open data formats, you're not reliant on a platform provider to get access to your data, right? It's sitting in an object store, it's registered in some data catalog, you have entitlements to get to that data, you're authorized to get to that data in that open table format, that data product in an open table format object. And then you can apply whatever compute you want to it that your organization supports. Compute engines, right? So Spark is a good example. Our AI Unlimited is a compute engine. The original name for AI Unlimited was, we called it compute engine, right? Internally from an engineering perspective. And that's what it is. It's not necessarily a database, it's more like a Spark cluster, and it accesses and is hydrated from open table formats in an object store, right? And then along the lines of AI Unlimited, the foundational, operational, and big data platforms, you know, that form the AI ecosystem, right? You're going to have a lot of this different compute. We'll talk about compute diversity or democratization of compute, right? Open table formats is kind of democratization of data in a way, with open data catalogs and using those, and then open democratization of compute within your businesses. You got a tool that you want to use, it runs in a certain compute engine, it can consume open table formats, go for it, right? But there's some trade-offs here that we'll talk about as well. So the objective being is the operationalization of AI-enabled analytics, right? And all the good stuff that we've been talking about this week and that you're concerned about or interested in from an AI or machine learning perspective. So the strategies at a very high level, this is a high-level conversation, right? All data begins and ends in the open data lake. Again, that's my generic term. Some might call it the open lake house. You can choose to call it whatever you want. But the basic is, I have an open data lake, all the objects are registered in a global data catalog, and anybody can get to it as long as they have the rights to do it, right? Tools and platforms on compute must leverage open data, right? So if you choose a compute engine, it must leverage that open table format. Pretty simple. You want to transition in the lower right-hand corner. Transition to open data and compute must occur, though, without business disruption, right? So as you convert, one of the big discussions we've had with some of these financial institutions and healthcare organizations and the U.S. Army was how do we shift to these open table formats? And I've got all this reporting, I got all these financial and regulatory things, right? And how do I shift to those table formats without rocking the user's world, right? In terms of what they're trying to accomplish. It's a big deal, right? So we need to kind of change the tires under the truck without them even knowing it, right? In a way, is what the business is saying. And organizations have found out the hard way that if they try to change it and make people rewrite a bunch of stuff, it's not going to go too well, right? Just because they want to go to an open table form. Business doesn't really care. Well, they do care, but not enough to have to rewrite everything, right? And then deploy cost-effective operational AI-driven analytics at a much higher scale based on all that open data and all that data diversity I just talked about, right? So those are the two modernization trends and strategies at a high level, and I'll talk a little bit more about what that looks like. Is there any questions? Does that make sense, just generally? Pretty straightforward? Okay, good, good. All right, so these are the high-level requirements, right? All data begins and ends with the open data lake. That was kind of the strategy, but it's also the requirement, right? All data must transition to the open data lake. So we got banks, right? They've got a couple petabytes of data in Teradata. They got a few petabytes in Oracle still, DB2, Snowflake, whatever, right? They need to transition that data to also be, or only be, and that's actually part of the trick here, in open table format. That's a big deal, right? And remember, do it without disrupting the business, by the way, right? And try to do it without having, like, always having 2 or 3 copies of that open table format data, the actual data, in 2 or 3 places, right? To transition to that one single version of the truth open data lake based on an open table format. This won't happen in 2 or 3 years. This will happen over 4 or 5 or whatever, right? But there's a lot of customers that have modern ETL pipelines based on PySpark and other things. They're replacing their proprietary ETL tools with, streaming and modern PySpark-driven ETL pipelines. And they produce open table formats. They also can load directly into Teradata and other databases, Snowflake, whatever, but they produce the OTF, and then we, as Teradata, are expected to help users consume those open table formats, right, that data. That's why OTF is a big part of our roadmap, which we'll get to in a little bit, but it's critical. And there's other critical nature of that we'll talk about as well. All data must be registered, the third point. All data must be registered, published via global data catalogs. You've got to register it, you got to publish it, you got to provide entitlements to it, and you have to manage it as an open table format, right? Those things still hit, but it's now you're in a more freer form environment. You're not relying on just one platform to do that, like a Teradata or whatever, right? You have multiple compute engines, and now they have to follow certain rules, right? And what happens if one compute engine is reading and another compute engine is writing or overwriting, which, right, could happen, because we manage that in a database. What happens in an open data environment? Whole nother discussion at a deeper level around federated data management in an open table format environment. Immuta, we've talked, I think we had a session yesterday, Immuta, kind of kicking those tires a little bit, right? But they haven't solved all these problems either, right? So if other storage, the last point, if other storage is needed for like performance, we'll talk a little bit about this, like block storage and Teradata to drive higher levels of performance, right, in I/O for more tactical workloads or more instantaneous query responses, the data must have lineage back to the open data lake, right? Meaning, like, if I have to have data in block storage, it should be lineage back to or consistent with what's in the open table format, right? Because the open table format in object store isn't necessarily going to have the I/O characteristics to match the performance that we drive in block storage that most of our customers kind of expect, right? And so we're figuring that out in engineering of how to promote things and integrate with that open table format, but still drive that high level of workload to get those subsequent query responses. How do you build a primary index on top of an open table format? That's what engineering's working on, right? So there's some major things. We had this discussion with a couple of guys over here yesterday, and businesses and other IT people say, oh, this will only take 6 months to transition this. Well, you can quickly create open table formats, but how do you transition all your data to that? And again, rule number 1, don't disrupt the business, right? So that's the big deal here, right? Just real quick, this is just a conceptual picture of the environment, right? So you now got all these open compute clusters doing all these different functions. I just listed some samples up on top, right? So open data sharing and reuse, you access the open data through NOS APIs, NOS Data Exchange, parallel connectors, push-down processing across those different compute engines. The world is so happy because now I can apply any compute to all that open, and the world is great. But this could get really complex really quick because now you've got so many compute engines, and you're going to have tech stack complexity built on top. You have things, who's aware of Microsoft Fabric here? A few of you, right? It's totally, mostly totally, a compute engine architecture built on something called OneLake. It really is a model of what I'm talking about here, right? It really is. Because it's OneLake, which is one lake to conquer all in multiple open table formats, all with compute engines. Remember I called AI Unlimited a compute engine? It's one of the key compute engines. The Microsoft chap this morning, our partner, talked about that this morning in the keynote, right? And how we're plugging that in and integrating within Microsoft Fabric. If you look at Fabric, that's kind of this picture, right? But how many tools do you need? And how many compute engines do you need? Compute engines, by their very nature, are very app-centric, right? And what I mean by that is, I have an application that needs some time series processing, or I'm just going to do some analytic modeling. There's a tool for that. You get a cluster. And then somebody else, they get a cluster. And everybody gets a cluster. But what about data centricity? What about multiple applications using the same piece of data in one compute engine, right? How does that happen? That hasn't been completely thought through yet. That's where you're still going to need your typical data warehouse foundational platforms, which I'll talk about in the next slides, that kind of centralize some of this processing and allows you to bring multiple applications to the data, not take all the data to all these disparate compute engines, right? Kind of a balanced approach, and you're going to need both, right? I wish the whole world could work around compute engines, but I don't think it's going to be as efficient as people think. It's going to be fairly costly in nature. So open compute requirements. Tool and platforms must readily consume open data. You should have saw that one coming. Tools and platforms must support open data management. How's that brokerage and how between a given element of data and how do that data get shared across multiple compute engines and who gets to read or write it or manage that data? That's all needs to be worked out. Must enable cost-effective open AI analytics, right? It must drive really high levels of analytic capability in a compute engine world, right? Integrated pipelines across multiple compute engines, how does that work, right? I mean, all these things in a compute engine world, it's good, but is it going to operate efficiently at scale? That's a key question, right? And needs to meet the requirements without excessive data replication and latency. So, if the compute engine has to replicate data within it, right, to do the work that it needs, then it becomes inefficient, right? And now, what's in my open data lake is copies upon copies of the same atomic piece of data. And that's where expense and data management headaches come from, right? So there's a lot of ramifications to this new strategy that we all together, as we go marching down the open data path, have to resolve as an industry, right? And they have not been completely resolved yet. So I believe, and this is actually the nature of the conversation I've had with a lot of customers, and I wasn't necessarily the one driving it. It was the customers driving the conversation to me. There's going to be some consolidation around some key platforms that are not necessarily compute engines. They're platforms that can produce and consume open data, but they might have multiple compute capabilities like Vantage, right? We have a vector store integrated in the platform, all right? I think I might have talked about that. We have time series integrated on the platform. We have analytics embedded in the platform. Being able to do everything around that as a pattern can be more efficient for certain application classes compared to compute engines, and compute engines will work great too for certain patterns. But just leveraging only compute engines and open compute or only big data platforms kind of limits your flexibility, right? So you want to bounce between both. And literally, this is a picture I kind of drew not just me, but the customer drew on the board. So this is a replication of something we drew on a whiteboard. Big data platforms, so it's either Hadoop still on-prem, or BigQuery in the cloud, or whatever, right? In some other cloud instance, right? On the right-hand side, it's all the generative AI analytic processing, right? It's the NVIDIA that we talked about this week, right? All the NVIDIA services in GPUs, right? So that's a major platform in this architecture, right? You're not going to have a lot of compute engines there because you've got to have a compute GPU farm to drive these huge large language models, right? All built around that open data lake. So when I have a vector embedding file, it's also going to be saved off as an open table format as well, right? So does that kind of make sense? I mean, we're going to go open compute, but then we need to focus and consolidate around a few key platforms. And I would argue, and of course I'm from Teradata, and this is a Teradata conference, so I can say this, right? I think Teradata has a good chance to be some. And in these institutions, banks and healthcare and other places, right? Teradata Vantage is one of those key platforms. Not the only, one of the key ones that operates in this open ecosystem, right? So there's some trade-offs to consider as we look at this, right? So transition open data, we already talked about this, keep hitting it, but avoiding business disruption as you do that transition, right? Low cost I/O data storage, S3, ADLS, Google Cloud Storage, cheap as all get out, but it's also relatively slow performance compared to block storage or, inline, NVMe spool or other things, right? And so you can't drive all workloads from an open table format in S3. You just can't, right? For certain performance levels. So you're going to have to move up tier the storage for the open table format to drive certain workload and query SLAs. We're working on that within Teradata engineering as well, a lot, right? Data replication for performance. Some platforms, like BigQuery, does a lot of data replication because it can't do a lot of multi-way joins very efficiently. It's true, right? And so to get by that, they do a lot of materialization of the data, pre-joins of the data really, within their environment and replicate it because storage is cheap. And now that's what the user wants. It's kind of like a bunch of BigQuery slots that are built for a BigQuery data mart. That's all serverless. It's all compute engine, right? The way BigQuery works. But there's a lot of replication. All that data is going to have to come out of OTF, get replicated, put in BigQuery format, or BigQuery will also support, I'm just picking on BigQuery, but it's true for every platform, right? And they're going to have to support OTF too. And how you support OTF is actually really important. It can't be a sidecar. It's got to be, for us anyway, it is going to be Iceberg and Delta Lake, Iceberg first, then Delta Lake, is going to be our primary cloud data storage format, period. It's going to take time to get there, right? But that's on the roadmap. We're taking it very seriously, what we're hearing from the marketplace and our customers. And so we're building that support directly in the platform as the primary format, not a sidecar, directly in the amps, directly in the platform to run as well or better than what we would with our own file system, right? And then we'll have to get, again, the EBS and everything else to work. Increasing AI requirements, cost to scale and sustain. In that compute engine world, how efficient will that be? It's a really big question, right? And how much resource utilization, if you spin up a compute engine, is it running at 100% or is it running at 40, 50%? In most environments, they run at 40, 50% if you're lucky. So that means while you've got it stood up, you're just burning cost, right? From an economics perspective, right? Leverage open compute, tech stack simplification, kind of talked about that, right? You've got to balance those things. And then compute performance and scaling, compute sprawl and underutilization. So real quick, trend from Bob here, right? What's happened in this industry over the last, 10 years, maybe less, is we basically have traded the cost of storage for excessive compute and underutilized compute in the marketplace, right? That's what we've done. as an industry, right? Compute is easy in the cloud. You spin it up, sits there, does its thing, but most compute is pretty excessive and it's underutilized, at least in what I've seen and talked to across many different customers, right? And we as an industry have to do something about that because it's not sustainable, especially as AI requirements skyrocket the growth of AI and analytic and data processing, right? So there's some trade-offs to consider there. So these analytic architectures have been and are still evolving, right? I'll redraw this in 5 years and it'll be something else, right? It's a constant evolution. And that's a great thing. That's a great thing because innovation is happening. But at some point, you got to settle on an architecture pattern and implement it and build and enable the business and don't disrupt them while you're doing it, right? So I just called it, in my term, you can call it a lakehouse. We already said that, but lakehouse is, it is what it is, right? It's an analytic warehouse, really. A trusted AI ecosystem like that, kind of like that picture I showed earlier, whatever it is, it's going to be different than what it is today around open table formats. And so Teradata, this is the Teradata, just a couple slides on position vantage. And this is as much, not just for you, but for our engineering organization to aspire to as well, right? We're not completely here yet, right? So Vantage eliminates the need to implement the 3 distinct design patterns of lakehouse, data lake, and warehouse. When your business wants to get something done, they don't come out and say, oh, I want a lakehouse. Maybe they do, if they're technically oriented, but most of them just want to get something done. And the patterns within the lakehouse are one thing, data warehouse, oh, I want a data lake. No, they just want to get something done with data. In this compute engine world, it's going to be all 3. You're going to need all of them, right? Depending on the pattern, what the application requirements are. So what I like to think is that Vantage Cloud Lake and other manifestations of our platform, like AI Unlimited, in this compute engine ecosystem, is really driving and can be one of those foundational. I'm staking a claim to it, right? As a company, I'm staking a claim to this open foundational architecture, and will also be a compute engine with AI Unlimited, and they might actually play well together, right? Along with many other compute engines that are available in the marketplace, right? Operational efficiency at true enterprise scale. So that's a challenge for us, right? So we operate at pretty efficient scale, and many of our customers, certainly in the banks and healthcare organizations that we work with, that's a challenge with open table formats. But we're really going to work really hard because we have to solve those, operational, high performance, high throughput scaling challenges based on open table formats, right? And we should do it without the users having to know they're even using OTFs, right? They don't care. They just want to get their job done, right? They don't care about our file system today. Why should they care about OTFs tomorrow, right? So that's, again, I'm talking to our engineering as much as I'm talking to you about this trend in the industry. And we are actively having these conversations, Dan Sperling, et cetera. Believe me, it's just front and center in front of our engineering organization. So anyway, so how Teradata meets, drives that, drive performance through support of open table format, ability to match storage to performance. So we're gonna pin or build views over the top of open table formatted data, put those in EBS storage to drive the tactical workloads that you expect today, or other methods that we use, right? Apply different types of compute to adapt to the application requirements. We want to play in the open compute world starting with AI Unlimited, but will be others as well, right? Leverage distributed query workload processing to bring processing to the data, more application or data-centric than application-centric, right, in the architecture. Deliver high levels of throughput performance on an efficient enterprise platform that is compute engine-based, open table format-based, and just, bless you, rocking and rolling, right, within the modern ecosystem, right? So that's Vantage Cloud, right? That's going to actually change a little bit over the next couple of years, right? This is going to morph as we go forward into this world. I'll guarantee it, right? Because I don't know what it is yet, but I know it's going to change, right? Because it has to. That's our platform. This is that picture of taking an OTF module within Teradata. For those that don't know Teradata, the AMP is Access Module Processor. It's the core data processing element, virtual processor, within Teradata, within Vantage, right? OTF support is open heart surgery right in the middle of it, right? It's not a sidecar, because that's how we're going to get performance out of this platform, around OTFs. And by the way, we'll have an OTF for Delta Lake. We'll have an OTF for Iceberg. We'll have an OTF for Hootie if it becomes popular. We'll have an OTF for Lightspeed. That's nothing, it doesn't exist yet, but that's my next OTF that I want to create, right? Whatever it is, right? We're going to have an OTF for it. And by the way, if I have Delta, you get sharing, a data sharing environment, you get Delta Lake files from your partners or Iceberg files from your partners. You can actually query both Iceberg and Delta Lake with this approach, because at the AMP level, it's been resolved. At the data processing level, it's been resolved. And so you don't have to worry about, you can actually join data between Iceberg and Delta Lake, right? It's wonderful. Well, wonderful, you know, am I getting carried away with that? But we're trying to isolate all that complexity from your users, from your DBAs, from really, you know, on top of the open data lake, on top of the OTFs. That's actually pretty cool. So you'll hear us call this native open table support. Engineering calls it C++ because it's coded in C++, right? But that's engineers being silly. Not being silly, they're doing really good stuff, but they don't know what to call things, right? So, but that is what we're building, and will be coming out in 2025. Can't tell exactly when yet, but 2025, right? Talk to Dan, don't talk to me. Talk to Dan Sperling. Anyway, but we have to. If we're going to be a consumption engine of OTF within our customers, like yours, we have to make it, and we have to make it work, right? And so I just put this in here. This is this actually helps you kind of see the world of open file format, open table format. Is it object store based? Is it block storage based? A block file system is what, if you're running Vantage Enterprise in the cloud or on-prem, you're here. You're right there, and have been for like almost 30 years, right? Since we redesigned it in 1995, 96 timeframe, right? I was on that team, by the way. I just did it again. I dated myself. But it's that drives a lot of performance, but the data can't all sit in the block file system. It has to resolve and reside and be managed in an open table format, but somehow brought into a block file system to drive the workloads that you expect Teradata to drive, right? And then, you know, the open file formats, all that big picture that I showed earlier, that's kind of your data structure and storage and format mapping within the architecture. And I think I got one more slide. So there's this balance between open data on the top, that's been the main focus of this presentation. And I have, on the right-hand side, efficient scaling utilization with adaptable compute. So we're going to work with different types of compute, different configurations against open data to scale compute effectively within the Teradata or AI Unlimited platform on the right-hand side. On the left-hand side is what I was talking about around match the storage type to open data to drive performance in SLAs. It's a database physics problem. I can't drive workloads with sub-second response times if my storage is slow, right? Just by the way, object stores are really good with throughput. They can push a lot of throughput and I/O, but it isn't necessarily for instantaneous record access. It's slow. It's just slow compared to EBS storage, right? And so we're going to balance between those. And we should do that automatically and not your DBAs, by the way, right? Because it's really hard to keep up with that stuff, right? And then on the bottom, right, it's optimize the workload and throughput, performance. That's that foundational element of the architecture I talked about earlier, right? Right fit storage, adaptable compute, optimize workload throughput, and price performance, right? So that's staking a claim for being a foundational system in this open data, open compute world that we're about ready to get into, right, as an industry. All trying to power all that cool AI stuff that we want to do, right? Right, I think I'm done. I'm done, thank you. Go for it.
No, you want to stay up here.
I'm going to, I can't run away.
You're going to stay up here with me.
You're supposed to answer the questions.
Thank you, Bob, for doing that. I have a microphone with Kimberly in the back, so if you have a question, put your hand up. I'll get us started. I'm intrigued that when I look at these environments and there is like extra ways that we can store data and there's more engines and it's, to my simple mind, I sometimes go, this feels like a lot of complexity in how we build something that is really fundamental, truth in data. So kind of give us your thoughts on, beyond the technologies that we looked at here, what other pieces do you think are going to become really critical in the architecture?
Well, I talked a little, first one, I'll restate the data catalog, right? And the importance of metadata in this architecture. And actually eventually representing metadata as an open table, as an open data exchange as well, right? So you're not, so when I use an open table format, I have open metadata that can kind of travel with it, right, if necessary, right? So that is important. The others is what I also mentioned around these, I'll call it data management brokers, right? The Immutas of the world or whatever, that becomes, is going to be really important. It's like a little compute engine that's sitting in the architecture that's basically helping with data management and making sure the data quality, the resiliency, et cetera, is maintained around those objects in the open table format world. That's basically taking the data management that we do as a database, that you expect a database to do, and completely opening it up as a service within the architecture, right? That is really needed in this open table format world. We will do as much as we can in that, but we don't own the data when we write it to OTF, like we own the data and manage the data in block storage today, right? Totally different world. But businesses, count on, the quality, making sure that data doesn't get corrupted, right? I/O paths to the data, all that fun stuff. It has to be maintained. It's just in an open world. So I think that's a huge one. There's others, but that's one of the biggest ones.
This question just in the front here.
Yes, sir.
Yeah. Thank you, Bob. Can you hear me?
Yeah.
Yeah. Thank you, Bob, for your presentation. So I have a question. I'm curious about. It's getting a little bit complex in the sense that we are moving from open data format in general into opening also compute, right? So
yeah.
how do you see it in the future, like having multiple compute engines accessing different sources of data with different concurrency between the different providers of the compute engine? Don't you think we are creating an additional governance of the compute itself?
Yes, absolutely. And I'll take it a little bit, how do I get an integrated pipeline across multiple compute engines?
Yeah.
Right? Because what happens a lot in these environments, I call it run and dump, right? So what will happen is, it is what it is, run something, dump a file. Another compute engine comes along and picks it up, right? Simple model for data exchange, but slow, right? I need a pipeline within the data fabric where I'm just passing data, maybe an OTF format, to another thing without persisting it in the object store, right? So I can get an integrated pipeline across it, right? And then who's going to piece all those pipelines, who's going to piece all those compute engines together to deliver an operational AI analytic application that has to serve 1,000 users a second, right? And do it in a sub-second. Right? So your question is spot on. I don't know the future. I just know the requirement because we can start doing that today, but now I'm decoupling, right? And as soon as you decouple, right, you got to put Humpty Dumpty back together again to deliver things for operational capability, right? So I think it's critical. What you said is critical, and there'll be brokers out there to manage, Workload management even is another one, right? Prioritization is another one. Open prioritization of these things, right? So think about all the services we provide and other vendors provide as a native element of their architecture, and now I'm distributing it, I'm federating it. It's hard. So your question is really a good one, right? So it's a good that it's open, but what's the balance, right, to that? That's great. Okay. Did I scare you? Other than, being kind of hyper today. That's where we're going, right? I think it's going to be cool, but there's some challenges behind it, right?
Maybe talk to us a little bit around, we're seeing this kind of world of data management kind of, I don't want to say split apart, but it's having more pieces in it. And we're seeing this world of AI sort of automagically doing all of these wonderful things out there.
Oh, it's automatic, yeah.
Yeah.
Absolutely.
So have you seen any places where we've seen the magic come together into the data management side of things?
I think there is an opportunity for AI to help with the data management side of things. I'll kind of maybe turn it around a little bit. I think there can be some really finely tuned models that focus on data management, right? And build me a business definition of this object based on the data in it. Or build me a definition of the data of this object based on the users or how the users are using it.
Yeah, cool, we've certainly seen that in sort of generative AI.
Yeah, exactly.
It's really good at summarizing things.
So, at the meta level, and again, Facebook was brilliant choosing meta because you want to use meta, right, all the time, but it's not Facebook meta, right? But at the meta level, I think AI has a really big role to play in this architecture. I really do, right? I don't know what all those services are, but if somebody wants to do a spin-off and, make us all millionaires, let's go for it, right? All on AI. It'll work. It'll work beautiful. That's correct. Yeah, so the question or the point is he was asking about that Teradata owns the data, manages the data in the block file system. We don't necessarily in the open table formats. Once we manage the data that goes into that format, if we're involved in the curation process or whatever, right? But once it's out there, it's managed by the data catalog, it's managed by the data management infrastructure within this environment, not us. We've separated ourselves from that. And that's a good thing because now it's more open. You don't have to go through us to get to it. But who's doing all that stuff that we did to manage that data before? That's my question, right? Yep. All right, cool.
Well, thank you one and all.
Good.
Bob, thank you.
No problem.